Hi class, it's Mrs. Kane, and today I'm going to be reviewing all of the material that I've taught the last week and a half in the e-learning unit. So if you've kept up with all the videos and you understand what you're doing, go ahead and just open the blank document and you can try the problems on your own. If you need a recap or there's some questions that are lingering, I'm going to go through each of the topics in this e-learning unit one at a time and try to clarify any questions that you might have. So the first topic I'm going to review is solving exponential equations. So this is the topic that we've talked about the last couple of days, and our goal when we're trying to solve for a variable in the exponent is to write each side of the equation with the same base. So if we look at this first set of examples, we have 2 to the 2x minus 1 equals 128. So the goal is to try to write each side with a base that is the same. So we're going to try to rewrite 128 with a base of 2. So we know that, many of us know that 2 to the 5th is 32. And so 2 to the 6th would be 64. And 2 to the 7th is 128. Okay, and if you want to use your calculator, you can also kind of use guess and check in your calculator. But just recognizing that 2 to the 7th is equal to 128. So we're going to rewrite the 128 as 2 to the 7th power. So now we have two expressions that are equal. They have the same base, and so that means the exponents must also be the same. So we're going to set 2x minus 1 equal to 7. Okay, and then it's a two-step problem. We're going to add 1 to both sides. 2x equals 8. Divide both sides by 2, and x equals 4. Okay, so for the next problem, 7 to the 9x minus 1 equals 343. So we're going to try to rewrite 343 with a base of 7. So we know 7 squared is 49, so let's try 7 to the 3rd. Okay, notice 7 to the 3rd is 343, so we're going to cross out the 343, and we're going to replace it with 7 to the 3rd power. Okay, now that the bases are the same, the exponents must also be the same. So we're going to set 9x minus 1 equal to 3, and then we add 1 to both sides. We get 9x equals 4, divide both sides by 9, and x equals 4/9. Okay, so in each of these problems, we just had to change one of the bases. Okay, the next problem, we're still solving for x, solving some exponential equations. The next one, we have 12 to the x minus 9 equals 1. And in these two problems, we're going to use a couple properties of exponents. The first property we're going to use is the zero exponent property. It says any base raised to the 0 power equals 1. Okay, so that means I can change this 1 and I can replace it with any base to the 0 power. So because I want my bases to be the same, I'm going to replace 1 with 12 to the 0 power. Now that my bases are the same, my exponents also have to be the same. So I'm going to set x minus 9 equal to 0. And then if I add 9 to both sides, I get x equals 9. Okay, in the next problem, we're going to use the negative exponent property. Okay, we know that if we have x to the negative b power, okay, we can write that as 1 over x to the positive b. We learned to drop it like it's hot. Drop it like it's hot. Okay, so in this problem, we notice that we have 4 to the x plus 1 equals 1 over 64. So if you use your calculator, or maybe you're familiar with 4 to the 3rd, 4 to the 3rd is 64. So if 4 to the 3rd equals 64, then 4 to the negative 3rd equals 1 over 64. So what we're going to do in this problem is we're going to replace the 1 over 64 with 4 to the negative 3rd power. Now that we have the same base, our exponents also must be the same. And so we're going to set x plus 1 equal to negative 3. And then if we subtract 1 from both sides, we get x equals negative 4. Okay? Now, in the last set of solving problems, what we're going to have to do here is change both bases. So we have 8 to the x minus 4 equals 32 to the x. So if we try to use 8 as the base, it's too big. 8 squared is 64, which is too big. It's bigger than 32. So we have to think of a base that's smaller than 8. Okay, so if you recognize 8 and 32 as having a base of 2, 2 to the third equals 8, and 2 to the fifth equals 32. So what we're going to do in this problem is we're going to replace the 8 with 2 to the third, and we're going to replace the 32 with 2 to the fifth. Now, we introduced a new exponent, and there's already an exponent there, so we have to use the power to a power property. So when we replace 8 with 2 to the third, we're then going to raise that 8, or 2 to the third, to the x minus fourth power. So we have to multiply 3 times the original exponent, x minus 4. And then the same thing on the right side, the new exponent 5 gets multiplied by the x that's already there. My Apple Pen just died. Okay, so we have to multiply that by x. Now that we have the same base, we're going to go ahead and set our exponents equal to each other. Make sure you distribute that 3. 3x minus 12 equals 5x. And then subtract 3x from both sides. Sorry, my handwriting is getting messy here. And then negative 12 equals 2x. And so x equals negative 6. Okay, so you got to be a little bit more creative when you have to change both bases. Okay, so the next problem, okay, notice that you can write 27 and 81 with a base of 3. Okay, so 3 to the third power is 27, so I'm going to replace 27 with 3 to the third, and then I'm going to multiply the 3 by the x that's already there. And then if we use our calculator, 3 to the fourth equals 81, and so I'm going to replace 81 with 3 to the fourth, and then I'm going to multiply the 4 by the x minus 3 that's already there. And now that I have the same base, I can go ahead and set my exponents equal to each other. So 3x equals 4x minus 12. And then if I subtract 4x from both sides, I get negative 1x equals negative 12. And then if you divide both sides by negative 1, x equals 12. Okay, so that's a quick review, kind of a recap of how to solve exponential equations. The next topic that I want to review is the compound and continuously compounded interest formulas. So the first problem says Tegan invested $400 into a savings account with an interest rate of 6% compounded monthly. Okay, and that's your key word right there. When you see the word compounded, if it says monthly, that's the compound interest formula. How much money will be in her account after 8 years? Okay, so if you see the word monthly, quarterly, semi-annually, annually, we're going to be using the compound interest formula that looks like this. Okay, the p-value is the initial amount that's invested, so in this case, $400. R is the rate written as a decimal, so 6% is 0.06. N is the number of times per year interest is compounded. So if it's compounded monthly, there's 12 months in a year, so N equals 12. And then T is the number of years, so in this case, 8. Okay, and then all you have to do is plug your numbers into your equation. So we get 400 times 1 plus 0.06 divided by 12. And then the exponent is 12 times 8. Okay, and you should be able to type that in your calculator exactly as it appears. If you have an older calculator or you're using a scientific calculator, you're going to want to put that exponent in parentheses. Okay, so you can always put the 12 times 8 in parentheses if necessary. Okay, and your answer should be $645.66. Okay, so that's when you use compound interest, if it's compounded a particular number of times per year. Okay, next one. Sean invested $600 into a savings account with an interest rate of 12%, compounded continuously. Okay, so some of you are having trouble with the continuous formula, so I want to review that. How much money will be in his account after 9 years? So when you read that word continuously, you're going to use what's called the PERT formula. Okay, the reason we call it the PERT formula is because it says A equals P times E to the RT power. Okay, so P is the initial amount of the investment, so in this case $600. E is a number. It's a button on your calculator. Okay, it's not a variable. R is the rate, so in this case 12%, 0.12, and T is the time, so in this case 9 years. So I'm going to go ahead and plug my numbers in, replace P with 600. You're going to write E, and then your exponent is 0.12 times 9. Again, some of you will have to put that in parentheses. So on the calculator, okay, you're going to type 600. If you hit second and then the LN button, which is 2 above the on button, it will type E on your screen and it will automatically raise E to the power. And then just type in 0.12 times 9 and hit enter. And your answer is $1,766.81. Okay? So continuously, that's how you know you're using that PERT formula. And then I wanted to review one just decay problem. So in 2000, oh, that should say 2017. That is a typo. I will fix that on your sheet. Sorry about that. Okay, so in 2017, Kara bought a new camera for $650. The value of the camera has depreciated at a rate of 20% each year since her purchase. Determine the value of the camera today in the year 2020. Okay, so we don't see the word compound anywhere. If we don't see the word compound, it's just exponential growth or decay. Okay, and in this case, we see the word depreciated, which means the value of the camera is going down. So we're going to use just the general decay formula. Okay, if it was going up, then we would just do 1 plus R, but because the value is going down, we're going to subtract R. So in this case, the value of the camera is $650. The rate of decay is 20% or 0.20, and we want to know the value of the camera 3 years after its purchase, 2017 to 2020. Okay, so all we're going to do here, we're going to do 650 times 1 minus 0.2, and then we're going to raise that to the third power. So 650 times 1 minus 0.2, okay, to the third power. And the value of the camera is going to be $332.80. Okay, and the last type of problem I wanted to review real quick is a graphing problem. So we're going to use the graphing calculator to graph this function, and then we're going to find the key characteristics and sketch a graph. So I want you to go to y equals, and we're going to look at one that has a base of e. So we're going to type -3, hit that second ln button, and we get e to the x plus 1 power. Oops. And then arrow over to the right and add 2. Okay, and then if we hit zoom 6, we'll all see the same graph. Now, when you're asked if this is growth or decay, you got to look at the base of the exponent. The base of the exponent is e, okay? And the value of e that we learned is 2.718. So e is approximately 2.718. So that automatically means that this is a growth problem. Okay, if you look at your graph, it looks like decay, but that's because the -3 is causing a vertical reflection. So it's actually a growth problem that's been flipped upside down. All right, so the x-intercept, that is also known as a 0 on your calculator. So go ahead and hit second calculate and select number 2, and you're going to try to find that x-intercept. So you're going to pick a point on the left of the x-intercept and hit enter, and then pick a point on the right of the x-intercept and hit enter, and then pick a point in between. Okay, we're going to round to 3 decimals, it says, so the x-intercept is -1.405, comma 0. Okay, so some of you keep saying there's no x-intercept, but if you see that it's crossing the x-axis, that is your x-intercept. So I'm going to go ahead and put that point right there. Okay, the y-intercept, you can find that by looking at your table. Okay, when x is 0, if we round to 3 decimals, it says -6.155. Okay, I'm going to go ahead and sketch that, negative 6.155, just get a little bit below 6. Okay, the domain is always going to be negative to positive infinity. And then let's look at the graph again. Now to find the asymptote, you're going to look at the vertical shift. Okay, notice we have a +2, and if you look at the graph, it seems to be flattening out around y equals 2. So that is indeed your horizontal asymptote. Okay, so y equals 2. Go ahead and sketch a horizontal line there. Okay, and then if we look at our table of values, we can look for one more nice point. We have a point at -1, -1. These 3 points are enough as long as you understand that the graph is going to approach the asymptote and then go right through these points that we have. Okay, and you can also use the graph. So the range, look from bottom to top. There's no minimum, so the range is going to start at negative infinity, and then it's going to approach but not touch the asymptote. So the highest y value that it's going to approach is 2. We use a parenthesis there because it never actually touches the asymptote. So I hope that review was helpful. If you have any questions, please let me know.